Picture a small group of early humans huddled together at the edge of a grassland. The sun has just gone down. The air is turning cold. Somewhere in the dark, a big cat is watching them, waiting for the right moment. These early humans have no weapons that can stop a lion. They have no walls. They have nothing except each other and the darkness pressing in around them. And then, in the distance, lightning splits the sky and a tree bursts into flame. Most animals run from that fire as fast as their legs can carry them. But at some point, one of our ancestors did something no other animal on Earth had ever done. They walked toward it. That single decision, to move toward the flame instead of away from it, is arguably the most important turning point in the entire story of human evolution. Everything that came after it, warm meals, safe nights, big brains, even the device you're using to watch this, can be traced back to that one moment of curiosity-beating instinct. So how did it actually happen? Not the myth version, the real version, pieced together from burnt bones, ash layers, and some genuinely clever detective work by scientists digging through caves on 3 different continents. Before we go further, it's worth asking why this question is even hard to answer. Fire itself doesn't fossilize. All that survives, if anything survives at all, is the aftermath, a smear of ash, a patch of reddened earth, a cracked rock that got too hot. Reconstructing how humans discovered fire means reconstructing an invisible event using nothing but its leftover shadow. Let's start with the obvious question. Early humans obviously couldn't strike a match. So where did that very first flame come from? The answer is almost certainly nature itself. Lightning strikes a tree, and a wildfire starts. A volcano erupts, and lava sets dry grass alight. Even certain rocks can throw off sparks if they crash into each other hard enough. Fire was already happening in the world constantly, long before any human ever controlled it. The real breakthrough wasn't creating fire out of nothing. It was learning to survive being near it, and then learning to keep it alive. That second part matters more than people usually realize. Scientists studying chimpanzees, our closest living relatives, have found something remarkable. In parts of West Africa, researchers have watched wild chimps encounter savanna wildfires and, instead of scattering blindly, calmly track which direction the flames are moving, wait it out from a safe distance, then walk straight into the burned area afterward to eat insects and small animals caught in the blaze. If chimpanzees can manage that level of understanding, it's not a huge leap to imagine early human ancestors, with bigger brains and more curiosity, doing something similar, and then pushing it one step further, getting close enough to feel the heat on their skin without flinching. From there, the next stage was what researchers sometimes call fire scavenging. Imagine a wildfire finally burns itself out, but a few branches are still smoldering at the edges. Instead of walking away, someone picks up a burning branch and carries it back to camp. Now you don't need lightning to strike again. You just need to keep that one branch alive, feeding it twigs and dry grass, protecting it from rain, passing the job of tending it from person to person. This is a completely different skill from making fire. It's about patience and responsibility. Let that flame die, and everyone goes back to eating raw meat and shivering in the dark until the next lightning storm rolls through, which could be months away. Evidence for this kind of fire use goes back a surprisingly long time. At sites in Kenya, such as Chesawanja and Kubifora, archaeologists have found burnt clay and reddened soil dating back roughly 1.5 million years, right around the time Homo erectus was walking the African landscape. Homo erectus is a fascinating character in this story because this was the first of our ancestors with a body plan similar to ours, walking fully upright, covering long distances on foot, and carrying a brain that was rapidly getting bigger with every passing 100,000 years. Many researchers think that's not a coincidence. Here's the logic, and it's genuinely clever. The human brain is an expensive organ to run. Even though it's only about 2% of your body weight, it burns roughly 20% of your daily energy, just sitting there thinking. Raw food doesn't release its calories easily, so a huge chunk of daily energy has to go toward digesting instead of thinking. Cooking pre-breaks the food down before it even reaches your mouth, so your body spends far less energy digesting and has far more left over to spend elsewhere. Once cooked food entered the picture regularly, evolution suddenly had room to experiment with bigger, hungrier brains. That's actually one of the most surprising parts of this whole story. Cooking wasn't just about taste or comfort. It was a massive nutritional upgrade. Heat breaks down tough muscle fibers and plant cell walls, kills off dangerous bacteria and parasites, and makes food dramatically easier to digest. A cooked potato gives your body far more usable energy than a raw one, for basically the same amount of chewing effort. Multiply that advantage across every single meal, for hundreds of thousands of years, and you start to see how something as simple as roasting meat over a flame could quietly reshape an entire species from the inside out. It's also worth remembering that Homo erectus wasn't the only member of the human family tree to master fire, and Africa wasn't the only place this story unfolded. Neanderthals, our close cousins who lived across Europe for hundreds of thousands of years, were once dismissed as dim-witted brutes who could barely manage basic survival. Cave sites across France, Germany, and England have turned up hearths and heat-treated tools strongly associated with Neanderthal occupation, and living through brutal European ice ages without reliable fire simply wouldn't have been possible. These were engineers of their own survival, using fire deliberately, season after season. In Israel, the site of Kesem Cave preserves an almost unbelievable level of organization. Excavators found a hearth used again and again for a staggering length of time, surrounded by a clear pattern: burnt animal bones concentrated close to the fire, stone tool production concentrated further away, almost like a deliberate floor plan. That's a group of people assigning different areas of their living space to different tasks. Cooking here, tool making there. A level of organization that's easy to underestimate when you picture cavemen as a vague idea instead of real communities with real routines. Now here comes the harder question, and the one that actually stumps archaeologists the most. When did humans stop just borrowing fire from nature and start making it themselves, on demand, whenever they wanted it? This is a genuinely difficult thing to prove, because ash and charcoal from a campfire look almost identical to ash and charcoal from a random wildfire that just happened to pass through the same spot. To get around this problem, scientists look for very specific clues. One of the strongest is finding fire evidence repeated over and over in the exact same tiny spot, layer after layer, over a long stretch of time. A wildfire is random. It doesn't politely return to burn the same 1-meter patch of ground 50 different times across 1,000 years. But a group of humans tending a hearth in the same corner of their cave? That leaves exactly that kind of pattern. Using clues like this, researchers have found strong evidence of deliberately maintained hearths at Wonderwork Cave in South Africa, dating back around 1 million years, and even stronger, more widely accepted evidence from sites in Israel, such as Kesem Cave, dating to around 300,000 to 400,000 years ago, where archaeologists found a thick, repeatedly used hearth surrounded by burnt animal bones and blackened stone tools. This wasn't a lucky accident. This was a group of people who had built their entire daily routine around a fire that lived in one particular spot. But actually striking a spark from nothing, without ever touching a wildfire, is a different skill entirely, and the evidence for that is rarer and much more recent. Two main methods eventually emerged. The first is friction, rubbing or spinning a wooden stick against a wooden base fast enough that the heat ignites a small pile of dry tinder. It sounds simple, but it takes real practice, strong arms, and exactly the right dry materials, because a single bit of moisture ruins the whole attempt. The second is percussion, striking a hard mineral like iron pyrite against flint at just the right angle to throw off a spark hot enough to catch. This is where one discovery in England becomes remarkable. At a site called Barnham in Suffolk, archaeologists uncovered tiny fragments of iron pyrite sitting alongside heat-shattered stone tools in soil repeatedly heated to over 700 degrees Celsius in the exact same small patch of ground, over and over again. Iron pyrite doesn't naturally occur anywhere near that site, so somebody had to find it elsewhere and physically carry it there, on purpose, the way you might carry a lighter in your pocket today. That detail is what convinced many archaeologists this represents true, intentional fire-making rather than fire scavenging. Not every expert agrees on exactly how early this dates back, and that healthy disagreement is a normal part of how science works. But even the skeptics agree something genuinely deliberate was happening at that site. What's genuinely humbling is that fire-making wasn't one light bulb moment that a single genius figured out and everyone else copied. Different groups in different regions, sometimes thousands of kilometers apart, appear to have learned fire-making independently. And in some cases, that hard-won knowledge was lost again completely when the people who knew it died out or got separated, leaving their descendants to start over from nothing but watching wildfires, exactly like their ancestors had. Fire-making wasn't invented once. It was invented, forgotten, and reinvented, again and again, across hundreds of thousands of years and thousands of miles. And once a group did have reliable fire, it changed far more than just their dinner. A fire pushes back the darkness, which means the day doesn't have to end the moment the sun goes down. Before fire, once darkness fell, there wasn't much to do except sit still and wait for morning. After fire, the night became usable time. People could keep working, keep talking, keep teaching each other, gathered in a small circle of light with the unknown pushed just far enough back to feel safe. Some researchers argue that the campfire was humanity's very first classroom, the place where an experienced hunter could show a teenager how to nap a sharper blade, where someone could describe which berries were poisonous before a child had to learn that lesson the hard way, where stories and hard-earned survival knowledge got passed down long before anyone had invented writing to record any of it. Fire also kept predators at a genuine physical distance, since most large predators are instinctively wary of flame. That meant humans could finally sleep on open ground instead of climbing trees every night, and could gather in larger groups without constantly scanning the darkness for danger, a shift that likely reshaped human social life for good. And there's one more effect that's easy to overlook. Fire let humans move into places they otherwise never could have survived. Cold climates and long winters were once hard biological boundaries. With fire, those boundaries started to dissolve, and groups could push further north into colder, harsher land than ever before. In a real sense, fire was humanity's first passport out of the tropics. So the discovery of fire wasn't really one single discovery at all. It was a long, uneven chain of smaller discoveries, stretched across more than 1 million years. First, watching flames from a safe distance without panicking. Then, carrying home a single smoldering branch instead of running from it. Then, learning to keep that branch alive for months, sometimes years, almost like a living thing that had to be fed and protected. And finally, after an almost unimaginable stretch of trial and error, learning to strike a spark from nothing at all, whenever it was needed. Every step in that chain took real courage, because it meant walking toward the one thing every other creature on the planet had spent millions of years learning to run from. That first person who didn't run, somewhere in Africa, watching a burning tree and feeling curiosity instead of fear, we will never know their name or their face. But almost everything that came after them, cooking, warm nights, bigger brains, tighter communities, stories passed around a flickering light, and yes, eventually, the screen you're watching this on right now traces its way back to that one decision, made in the dark, to walk toward the flame instead of away from it.